Okay, this is a worked example that we're looking at, and in this question we're looking at the exponential distribution. So suppose that the average waiting time for queuing in a bank is 10 minutes. Okay, so that's the typical type of exponential problem. Now really I should specify that this is assume that x is exponentially distributed. That really actually, now that I think of it, should be there stated explicitly in the question. But let's continue anyway. So here we're told that mu is equal to 10 minutes, okay? And that means that the rate parameter is 1 over 10, okay? That's the rate parameter. Now, I'm going to do something particularly in particular in this video, so this is probably not a good one to sort of start with. But if so lambda is the rate parameter, okay? I'll come to that shortly as what is unusual about this question, or particular. So probability of x greater than or equal to 15. So x is our lifetime, our queuing time. Queuing time. I think that's how you spell queuing. I don't know if there's an E at the end. So x is an exponential random variable. Sorry, I should actually specify in minutes, because sometimes you could switch from minutes to hours or something like that. So x is an exponential random variable with a rate parameter of 1 over 10. Okay, the reason is if you switch to hours, that changes the rate parameter accordingly if it's denominated in hours. Okay, so that's how we'd start off our question. Now I'm going to sort of skim past the formula here, but this is a key one here. Probability of x greater than or equal to k, where k is some waiting time, is the exponential of minus k times lambda. So in this case, the probability of x greater than or equal to 15 is e to the power of the exponential of minus 15 times lambda. That is 15 times 1 over 10, which is 1.5 essentially, or 3 over 2. So essentially what we're calculating is the exponential of minus 3 over 2, which is 22% approximately. Okay, now this is the unique selling point of this question. This is why this question is particularly unusual in regards to the others. It relies on the memoryless property of the exponential distribution. Okay, so this means that I'll just tell you what it means as we go through the question. Actually, this is the memoryless property, and this is what is particularly important about the second part here. So what is the probability that a customer will spend more than 15 minutes in the queue in the bank, given that he's been in the bank in the queue already for 10 minutes, okay, or they have been, okay? So this is a sort of assuming that you're in the bank and you've been queuing there for 10 minutes, okay? What is the probability that you're going to be queuing for 5 more minutes? Now, this is according to the exponential distribution, that things might be worked differently in the real world, okay? So that's how we would sort of state the question there. Probability of x greater than or equal to 15, given that probability of x is greater than or equal to 10. Now the memoryless property of this specifies that it's almost like you sort of walked into the bank straight away, okay, and you just started to queue the queue. But in this case, if you just sort of reset your watch, so to speak, the probability of waiting more than 15 minutes, given that you've just been in there for 10 minutes, is the same as just walking in and waiting for more than 5 minutes. Okay, that's really the gist of it there. Okay, so that's the memoryless property. So it's sort of resetting the clock after 10 minutes, if you get me. Now, so how do you calculate that? That is the exponential of minus 5 times 1 over 10, which is a half. So the exponential of minus a half. So the answer to the second one is 0.604, approximately 60%. Okay, so that's that question done. So the key feature of this question, as you can tell, is the memoryless property of it, and that how you would use that in a conditional probability question, just like we have here. So remember to actually state it. Just write that out. By the memoryless property, we could sort of say this is equal to this. Okay, the memoryless property of the exponential distribution. All right, okay, we're good. Good, so we'll leave that there.